school calculus, application of calculus. This video is to show you how calculus is used to solve the physics and engineering problem. These are kind of advanced topics, and most of high school probably don't cover this kind of subject, except for maybe Chinese. The Chinese college exam ask a question about special relativities. I was quite surprised. But most of the high school in the United States don't cover. This is the college levels. So if you like, you can skip it. But if you think you're very good at math and physics and stuff, you should definitely go for it. This is very anyway, you do that in a college. So second derivatives pendulum problem. Okay, it is known that pendulum moves as sine function x equals a sine bt. Find a and b. Well, what this means is you have a pendulum swinging. This distance is x, time of function, right? And pendulum has mg, that's a force. The gravity g is the acceleration, and actually acceleration is this component when the swing is not too big. It's almost parallel to this. Okay, so what happened is, since x equals a sine bt, the speed v equals x over dt equals a b cos bt, right? Then acceleration is second derivative ab square minus sine bt like that, right? And this acceleration is this is theta g cos theta omega t. Okay, so you have g cos omega t, bring it here, the ab square sine omega t bt over cosine bt, and this is a negative direction, so negative cancelled out is 0, right? So b is 2 pi ft. This is omega t. Omega is 2 pi f, right? And ab square equals g. So a is actually g, gravity, divided by 2 pi f square. Okay, so here's the answer. When the maximum swing is L theta 0, where theta 0 is radius, is the initial swing angle, what is the period of the pendulum? Well, if A is L theta 0 equals g 2 pi f square, then t is 1 over f. So you can calculate, right? Okay, so calculus, differentiation. Application of differentiation. A string has L meters total. We connect both ends and make a rectangle shape. Find a rectangle that will have a maximum area. Well, this one actually we did that in the quadratic equation, but we use calculus this time. Total L, right? Now, this is X. Okay, so this one is L minus 2x over 2, right? So area is X L 2x over 2. So find the maximum. That means ds dx 0. Could be minimum, right? So you have to take the second derivatives. So this is xl over 2 minus x squared. So ds dx equals L squared over 2 minus 2x 0 x L squared 4. Okay. Oh, no. Where does L squared come? L squared 4. So that means this, not the rectangle, square give you the largest area. So if you take a second derivative, L minus 2, and this is positive. Oh, no, I'm sorry. Minus 2, negative. That means this is a max value, max. Okay. The cost of manufacturing TV set decreases as the quantity increased by the formula when n is the number of the unit, when the profit is calculated by the following formula. What is the n that maximizes the profit? S is the price of TV, and this is the cost of marketing. Okay, so what you do is you take a derivative, set the 0, so you get the n. And second derivative, make sure this is negative, then it's a max. Okay. Next question. We covered this already. This is interesting problem. The linear stick of length L to the vertical wall Y from the corner of the point M that divides the stick by the 2:1 ratio is a line D. Find the angle theta that makes the distance B minimum. Distance B minimum. So this is the B. Okay. Since it's a 2:1 ratio, A and B is 2.2 to 1, similar triangle, right? The length of the segment MN is this. Therefore, D square equals A square plus M minus N square, and you plug in that. And now you take a derivative, set the 0, and sine theta cosine theta equals 0 is a possible answer. So the range is 0 to pi over 2. So Answer is pi over 2. Okay. Calculus, application of integrals, integration. The work is defined by force times distance. The radius, rest radius. What's rest radius? The typo. R0 is a 1 kilogram object on Earth. This is Earth. Surface is moving to the outer space far away. How much energy is necessary to do so? I assume the gravity force is this. Okay. So you take an integral from your position R0 to all the way infinity. From here, R0 to infinity. And you have a gravity pulling, move against this gravity, so you need a work, you need energy. So you need this much energy to move unit mass all the way to the end of solar system, because solar system, the dominated gravity is the sun's gravity. So you need this much, right? The density of mud in a swamp varies depending on the depth. The density function is this, where x is depth and d is density. When the machine sinks to the depths of L, what is the pressure it gets from the mud? Okay, this is the engineering problem. So whatever in the liquid you put the machine get the pressure. How much pressure does it get? It's not uniform water, okay? The density change. So you have to take an integral from 0 to L, this density. So this is the pressure per square meter. Okay. Next one. Bend the wire into the parabolic shape as shown below. Find the center of gravity. The total length of wire is L meter and total weight is N kilograms. This sounds like a engineering or physics problem. So you have a wire. What you do is take the density low per meter, the weight, and you take a integral so you can tell total weight. Okay, if any wire you have a density low kilogram per meter, you take integral, you can tell the entire weight. Okay. Calculus differentiation. Newton's law. I think we covered this in the differentiation section, right? This is a review. We have F equal ma, and A is second derivative of distance function by time. So if you take an integral and set the constant properly, initial velocity and initial position. This is initial position, this is initial velocity. So the distance function is going to be square plus vt t plus h0. Okay. When gravity 10 kg for the mass of 16 kg, what is the acceleration of this planet? Earth has the acceleration of which planet is this in the solar system? So if you calculate It's a 1/6 gravity, so it must be moon, right? The Earth is 9.8. Moon has a 1/6 of the gravity. A boy tossed up a 0.1 kilogram stone vertically from your height. So we use from height 1.5 meter already, so it's a h0, and m is 0.1 kilogram. The initial speed v0 is 2 meter per second. Okay, so using this distance function, you have all the parameters set for you. Okay, find the max height. Well, you take a derivative, which is velocity. Velocity becomes 0. That means it goes up, and velocity becomes 0 and become negative. It's come back. How high did the stone go up above the person? So that's simple question. Okay, application of differentiation, Newton's law. Okay, we know this, right? So we apply this to pendulum. So you know mg divided into ft and fx. Fx is negative mg sine theta equals ma. So a is this. Now if theta is small, we can approximate, okay, because limit theta 0 equals 1. Okay, so if we use that, then we can get the second derivatives. So we did this question already. Now maximum swing, the Hooke's law. Hooke's law, from this center to moving distance is x. So Hooke's law said acceleration is Hooke's constant and distance. Okay, and distance go by sine wave. Okay, so omega is the frequency related parameter and the k is amplitude. Okay, that's a Hooke's law. Oh, here, application of integration. We did this, right? After you take an integral, you have to set the constant. The constant is set by the physical condition. Application of integration, work is defined by force x distance. Okay, we did this. Okay, it's just remaining the repeated same question. Okay, so that's the end of application of calculus. It's just a brief overview of what you can do with calculus. Okay, so some of subject is actually college levels, but advanced high school student can go ahead and review this and get idea about what you can do to solve the problem with calculus. It's a powerful math tool. I hope you enjoyed listening this video, and I'll see you in the next video.